Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at some practice problems that deal with the law of signs, the ambiguous case. Let's go ahead and get started. So before we actually jump into the actual practice problems for this video, I want to show you a cool little visual that one of our other pre-cal teachers showed me. So one of our other pre-cal teachers, Mr. Moskowitz, or Mr. MK for short, he showed me this cool little visual. So let's consider a triangle where the angle that's given to us is angle Z, the side across from the given angle will be Y, and the side that's not across from the given angle will be X. Well, if we trace from the angle to the side across from the given angle and we trace through the other side, well, if this side on the way to the side across from the given angle is smaller than this side, the side that's across from the given angle, then we actually fall into a one triangle scenario because this angle Z can be thought of as the given angle, and this side X can be thought of as that, that B side that we're looking at in the notes. And you can see it actually works really well. So if we jump over to our notes here, for each one of these one triangle scenarios, we'll notice that B, remember that B represents the other side, the side that's not across from the given angle. Notice that B is smaller than A in each of these one triangle scenarios. And remember, A is the side across from the given angle. And that's exactly what this is saying. So again, one more time, if we have an angle Z and we trace along the triangle to the side across from that given angle, well, if the other side ends up being smaller, then we would fall into a one triangle scenario. And now let's look at kind of the opposite. We have the same setup. Here's angle Z, and if we trace along to side Y, in this case it's Y, or if we trace along to the side across from that given angle, well, if the other side ends up being bigger, then this turns into an ambiguous situation. Ambiguous meaning there is either 0 triangle solutions or 2 triangle solutions. So if that side on the way to the side across from the angle is bigger, then we have the ambiguous case with 0 triangle solutions or 2 triangle solutions. So I thought this was a really cool visual, and we're going to end up using it here for the practice problems. We're going to try it out. Okay? So in this practice set, there's 12 different problems. And what I'm going to do is I'm going to work through 4 of them with you. And hopefully that'll be enough to kind of get you started, to kind of set you on the right path so you can try the other 8 problems on your own. I'm going to be working through problems 1, 2, 5, and 6. So let's get started with number 1. In number 1, we want to state the number of possible triangles that can be formed using the given measurements. So notice we're not trying to solve it, we're just trying to figure out how many triangle solutions are possible. So let's go ahead and let's try out Mr. MK's method here. So we draw a triangle. Here's measure of angle A, 68 degrees. We can see that across from angle A is side A, which is 9, and the side that's not across from the angle is 34. And if we trace from the angle to that side across from the angle while going through the other side that's given, we can see that the other side that's given is bigger than the side across from the angle, so we fall into the ambiguous case. Ambiguous meaning there's either 0 triangles or 2 triangles. Well, let's go ahead and calculate H. Remember, H is that altitude, and we're going to calculate H because the angle given to us was an acute angle. So remember that to calculate the altitude, it's the sine of the angle you're given times the side that's not across from the angle. So we get 34 times the sine of 68 degrees, and that gives us 31.5. So what that's telling us is that A, or the side across from the given angle, is smaller than the altitude. And that's going to tell us that there is no triangle solution. And let's verify with our little table from the notes. So again, we knew that it was either a no triangle or 2 triangle scenario. That allowed us to cancel everything with the 1 triangle scenario. Well, we also knew it was an acute angle, so that allowed us to get rid of this right here. So we fall into one of these two categories. Either A is less than H, remember A is the side across from the angle given, or A is going to be bigger than H. Again, H being the altitude, A being the side across from the angle given. And we can see right here, with H being 31.5 and A being 39, or sorry, not 39, but 9 rather, we can see that H, the altitude, is much bigger than the side across from the given angle. So that puts us in this scenario, meaning we have no possible triangle solution. So Mr. MK's method working pretty good so far. So go ahead and circle that answer, none. All right, let's try it again. Let's see if it works 2 times in a row. So we want to state the number of possible triangles that can be formed using the given measurements again. Let's go ahead and draw the triangle. So we can see that here's angle B, 61 degrees. The way that I have it set up, A is 35, and B, which is across from the given angle, is going to be 32. So once again, tracing from that given angle over to the side across from the given angle, we can see that the side on the way to it was bigger. So we ran into the ambiguous case, meaning that there's either 0 triangles or 2 triangles. Well, once again, we have an acute angle here, so let's go ahead and calculate the altitude. Altitude is going to be the sine of the angle given times the side that's not across from it, so 35 times the sine of 61 degrees, and we get 30.6. So this time, notice that the side across from the given angle is bigger than the altitude. And if we look at our notes, go back to that table from the previous lesson, we can see that falls into the 2 triangle scenario. A is acute, check. The side across from the angle is bigger than the actual altitude itself. Okay, so that puts us in the 2 triangle scenario. All right, so that cool little visual that's coming from Mr. MK works great. Everything is checking out perfectly fine, and so feel free to use that if it helps you out. Okay, let's now try numbers 5 and number 6. So number 5 says solve the triangle, round your answers to the nearest tenth if necessary. And notice that all these problems here, they all have 2 solutions, 2 triangle solutions. Meaning, because we can see this through the multiple choice, we don't need to guess as to how many solutions it have. We can tell there's 2 triangle solutions. So I went ahead and set up each of the triangle solutions. So the information that we're given with is going to set up the triangle the same to begin with for each of the triangle solutions. We can see we have angle B is 27 degrees in both triangles. We can see that A is 28 and that B is 18. B, that 18 being the side across from the given angle, which is 27. So let's work on solution 1, triangle solution number 1. And here we're really just going to work through the problem like normal. We can tell that we have angle B, we have side B, we have side A. So really the only thing we can do first is find angle A using the law of sines. So that's what I set up here. Sine of angle A over A equals sine of angle B over B. Plug in the pieces. Notice that angle A is the only thing left to solve. Then we go ahead and cross multiply. We get 18 times the sine of angle A equals 28 times the sine of 27 degrees. Divide both sides by 18. And then finally, to isolate the A, we take the inverse sine of both sides, and making sure that this is all set to degrees and whatever kind of calculator you're using will get you the angle A is about 44.9 degrees. Okay, so we can put that on right there. Now that we know angle A and we already knew angle B, the next logical step is to find the measure of angle C. And that's pretty easy because if we already know the other 2 angles, well, we just subtract them from 180 degrees and we get that the measure of angle C is 108.1 degrees. And then finally, the only piece that we're missing now is side C. So we use the law of sines. I personally decided to set it up as sine of angle B over B equals sine of angle C over C. Plug in the pieces, cross multiply, isolate for C, and we get that C is equal to 37.7. Okay, So that gives us our first triangle solution, but we know that there's going to be two triangle solutions, two possible triangles that meet these given measurements. So to find the second triangle solution, remember that the first step that we're going to take is we're going to look at that first angle that we found. The first angle that we calculated for was angle A. Well, let's take its complement. So taking the complement of angle A, so taking the complement of 44.9 degrees, we get 135.1 degrees. Remember, the complement is just where you take that angle and you subtract it from 180 degrees. So the new angle A, or the angle A in the second triangle, is 135.1 degrees. And once we have the new angle A, well, the new angle A and the angle B that we knew that we had to begin with, we can use those to find the new angle C. So 180 degrees minus those two angles gets us 17.9 degrees. And then lastly, all that's left to find is the new side C. We set up another equation using the law of sines, and we get that C is equal to about 12.2. Right? So going over to our answer choices, that puts us right here. So that's a really good example of how you would use the law of sines to solve a problem that has two potential or two triangle solutions. All right, in the last example we're going to work through, and then I'm going to leave all the other ones up to y'all. We want to find the measure of side B given this information right here. So just as with all the other problems, I'm going to go ahead and set up the triangle. And I'm going to use Mr. Moskowitz's cool little visual. Notice that measure of angle A is 32 degrees. The side across from angle A is 17. And the side that's not across from the given angle is 5. And that turns out to be across from angle C. So tracing from the angle to the side across from the angle, making sure to go through the other side, we can see that this is going to run into a one triangle scenario, because we can see that the side we end up going through is smaller than the side we end up on. So if it ends up being smaller, that side we run through, that gives us a one triangle scenario, meaning we can solve this one just like a normal problem. So thinking about how we're going to solve it, we have angle A, we have side A, we have side C. So we need to start by finding angle C, and that's the first step that I take. Use the law of sines, plug in the pieces we have here into sine A over A equals sine C over C, and we end up getting that C is about 9 degrees. Once we know that C is about 9 degrees, use that 9 degrees in combination with the 32 degree angle that we already know, subtract them both from 180, and we get the measure of angle B to be 139 degrees. And then, of course, once we know that B is 139 degrees, then we finally have to find side B. So I set it up as sine of angle A over A equals sine of angle B over B. Cross multiply, isolate for B, and we get that B ends up being 21. And this is our final answer, because we were asked just for the measure of side B. Okay? So once again, these are just a couple practice problems. All the other ones are going to be left up to you. Most of these are ambiguous case problems. I believe the last two, if we jump to number 11 and 12, yeah, it says it right here. Number 11 and 12 are not ambiguous case problems. These are just normal law of sine problems. So a little bit easier in my opinion, but still good to practice.